Hello, today's video is going to be about trig ratios. So first of all, what is trigonometry? Trigonometry is the study of triangle measurement. And each acute angle of a right triangle has the following trigonomic ratios. So sine is the ratio of the leg opposite the angle to the hypotenuse. So in a right triangle, the hypotenuse is always the longest side. So for this example, the hypotenuse will stay the same regardless of which angle we're talking about. But to find sine of angle A, like it asks us to, we need to know which side is opposite of angle A. So this is angle A, and the one opposite of it is side A. So that means that sine of A is A over C. Now, to find sine of B, of angle B, we need the side opposite of angle B, which is going to be side B. So sine of B is B over C. Now, if we look at cosine, cosine is the ratio of the leg adjacent to the angle to the hypotenuse. So again, the hypotenuse is the denominator for cosine as well. So we know that the denominator for both of these is going to be C. But instead of the angle or the leg opposite that angle, we need the leg adjacent to the angle. So to find cosine of angle A, first of all, if it's not the hypotenuse in a right triangle, these are both legs. So you have two legs and a hypotenuse. So which leg is adjacent to angle A? Adjacent means next to or touching. So that's going to have to be angle B because the hypotenuse is not a leg, so it's not an option. So B over C is cosine of A. Then to find cosine of angle B, we look at which leg touches angle B or is adjacent to angle B, and that's going to be A. So cosine of B is A over C. Finally, tangent is opposite over adjacent. So tangent of A, if we have angle A, the opposite leg is A and the adjacent leg is B. So opposite over adjacent would be A over B. Then to find tangent of angle B, we want opposite, which is B, over adjacent, which is A. So it's going to be B over A. Now in the next section, whenever we talk about the word SOHCAHTOA, which hopefully you've heard before, it's just a way to remember these equations. So that the SO comes from S-O-H, the CA comes from C-A-H, and the TOA comes from T-O-A. And it tells us these equations. So we have SOHCAHTOA. And that stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. So for number one, it wants us to find sine, cosine, and tangent of A, and then sine, cosine, and tangent of C. So I'm going to label these for A. So if we're talking about angle A, the side opposite of angle A is going to be 5. The leg adjacent to angle A is 12, and then 13 is the hypotenuse. The hypotenuse is always the longest side of the triangle, and it's also always across from the right angle. So now we just have to plug in our equation. So sine, the equation for sine is opposite over hypotenuse. So that's just going to be 5 over 13. And that's your answer. Cosine is adjacent over hypotenuse. So that's going to be 12 over 13. And tangent is opposite over adjacent. So you're going to get 5 over 12. Now I'm going to relabel these for for angle C. And the hypotenuse stays the same, but your adjacent and opposite sides switch. So sine of C is going to be opposite over hypotenuse, so 12 over 13. Cosine of C is adjacent over hypotenuse, so 5 over 13. And then tangent of C is opposite over adjacent, so 12 over 5. On number 2, you're going to notice that we're missing a side. We don't know what that side is, and that side happens to be the hypotenuse. We're going to have to use the Pythagorean theorem to figure out what this third side is. The Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse and a and b are legs. So what we don't know is the hypotenuse. So we're going to have 9 squared plus 12 squared equals c squared. This is going to be 81 plus 144 equals c squared, which is 225 equals c squared, which just gives us c equals 15. So this side will be 15. So now we want to find sine of w. Sine of w is going to be opposite over hypotenuse. The side opposite of w is 12, and the hypotenuse is 15. But this fraction can be reduced, so we want to reduce it to 4 over 5. Cosine of w is adjacent over hypotenuse, so that's going to give us 9 over 15, which reduces to 3/5. And tangent of w is opposite over adjacent, so 12 over 9, which reduces to 4/3. Then we're going to look at the x angle. So sine of x is opposite over hypotenuse, so we're going to get 9 over 15, which reduces to 3/5. Cosine of x is adjacent over hypotenuse, so that's 12 over 15, which reduces to 4/5. Then tangent of x is opposite over adjacent, so we're going to get 9 over 12, which equals 3/4. I'd like for you to pause the video here and try number 3 on your own. I will say that you should pay attention to the Pythagorean theorem here, because the one that you're missing is a leg, not the hypotenuse. So you can either set this up as a squared plus 16 squared equals 34 squared and solve for a, or you can set it up as 16 squared plus b squared equals 34 squared and solve for b. Either one of these will get you the same and the correct answer. So here is all the correct work so that you can check yourself. Let's take a look at numbers 4 and 5. On these, instead of finding what sine and cosine and tangent are, we're going to use those things to find the length of a missing side. So if we look at number 4, we know angle 28. So we're going to label the sides in respect to that angle. We know that 19 is going to be the hypotenuse because it's across from the right angle, and it's obviously the longest leg or the longest side in this triangle. X is going to be the opposite side because it is opposite of 28 degrees. So we have O and H. So we want to use our formulas from SOHCAHTOA to figure out which one of the trig functions, sine, cosine, or tangent, goes with opposite and hypotenuse. And that's going to be sine. So if we set up our equation, sine of the angle, which we now know is 28 degrees, is going to equal the opposite side over the adjacent side. Over the hypotenuse. And we want to solve for x. So since we are dividing by 19 here, the opposite would be to multiply by 19. So we're going to have 19 sine 28 equals x, and then we can just type this in our calculator. So before we type it in our calculator, we always need to check the mode of our calculator. And if you go to mode, which is the button beside the second button, and go down to the third row, you should go over and select degree instead of radian. And you should check this every time because sometimes we'll use radians and sometimes we'll use degrees, and you always should make sure it's in the right category. So we are typing in 19 sine 28. So we're just going to type in 1, 9, and then sine is right here. 28 and hit enter, and you're going to round to 1 decimal point. So for this function, we are going to get x equals 8.9. All right, so on number 5, we're going to repeat this process. We know angle 41 degrees. This x is opposite the 41 degrees, and the 32 is adjacent to the 41 degrees. The hypotenuse is over here, but we don't really care about it because it doesn't have any label. So we want to find the trig function, sine, cosine, or tangent, that uses O and A, and that's going to be tangent. So tangent of 41 equals opposite over adjacent. So once again, we will multiply because that 32 is on the bottom. And we're going to get 32 tangent 41 equals x. And when we type 32 tangent 41 into our calculator, we're going to get that x equals 27.8. I want you to pause the video and try numbers 6 and 7 on your own. Then come back to check your answer. Here are the correct answers for number 6 and number 7. So you'll see that I've titled this slide, Examples when X is in the denominator. These are going to look slightly different than the examples we've done so far. So in number 8, this is the opposite leg and this is the hypotenuse. So we're going to use sine. Sine of 33 equals opposite over hypotenuse. So we are now dividing by x. We are not dividing by 15. So we kind of have to do 2 different steps to get this to work out. We're going to multiply by x to get the x over here. So we're going to have x sine 33 equals 15. Then we can get x alone by dividing by sine of 33 to move it to the other side. So we're going to get x equals 15 over sine of 33. So what that looks like in our calculators is just 15 divided by sine 33. So the answer to this one is going to be x equals 27.5. All right, so for number 9, we have the hypotenuse and the adjacent leg. That is cosine. So cosine of 43 equals adjacent over hypotenuse. So once again, x happens to be in the denominator of our fraction. So we bring the x over first and get x cosine 43 equals 36. Then divide by cosine 43 to get 36 over cosine 43. Then when you type that into your calculator, you should get an answer of 49.2. I'd like for you to pause the video and try numbers 10 and 11 on your own. Here are the correct answers for numbers 10 and 11. All right, now let's try a word problem. So these are exactly the same as the problems we've already been doing. You just kind of have to draw a picture first. And since we're working with trig functions, it's going to have to be a right triangle. So there's not really too much to figure out. This says Jake leaned a 12-foot ladder against his house. So I'm going to stop right there. And when I lean a ladder against a house, I'm going to see where is the triangle in that image. And so our ladder is leaned. This is going to be our house, and this is going to be the ground. Okay, so ground, house, ladder. So this should be our right angle because usually the ground is flat and houses are upright. And it tells us that the ladder is 12 feet long. So we know that this side, or the hypotenuse, is 12. It says if the angle formed by the ladder and the ground, so that's going to be this angle, is 68 degrees, how far from the base of the house did he place the ladder? So it wants to know what this value is. So if we're looking at just our triangle now, we don't care about the real world part of it, just look at the triangle and the numbers. We have the adjacent side and the hypotenuse. So that tells us to use cosine. So cosine of 68 equals adjacent, which is x, over hypotenuse, which is 12. So we're going to multiply by 12 to get x. And when we type 12 cosine of 68 into our calculator, we get 4.5 feet. That is how far away from the house he placed the ladder. All right, so I want you to try number 13 on your own. I do have the answers here when you're done, but go ahead and pause the video and try this one. And here is the answer to number 13. Thank you guys so much for watching, and I hope you have a great day.